You have to break the problem down into 4 simple steps. You divide, multiply, subtract, and bring down. Do it over and over until the quotient is found.
Before we break the long division problem down, here's a couple of terms that you're gonna hear about.
Divisor is the number that goes into another. How many times it can is what you will discover. The dividend is the number being divided. You know that weird looking bracket? It's the number inside it. Quotient, now that's another term for the answer. It's a fancy word, but it's what your teacher will prefer. And you get a remainder sometimes when the dividend doesn't equally divide.
Divisor, dividend, quotient, remainder. Divisor, dividend, quotient, remainder. When you do long division, here's what to expect. You have to break the problem down into 4 simple steps. You divide, multiply, subtract, and bring down. Do it over and over until the quotient is found.
Hey everyone, and yes, you guessed it, we are going to be talking about long division today. This is 4.3 out of the big ideas. We're dividing polynomials, and one of those ways is to use long division. As you can see here, what we'll learn. We're also going to learn a little bit of a shortcut method called synthetic division as well, and also look at what's called this remainder theorem. So before we get into that, let's go ahead and just look at a little quick cartoon of the day. So Far Side cartoon. You got some, looks like they're bowls or something. Yeah, it looks like they may be like bowls here in a china shop. The two ladies in the back say, I got a bad feeling about this, Harriet. Kind of reminds me of that that movie that came out not too long ago, Ferdinand, where he was in this china shop. That was always a nice little fun movie. Alright, so going on to our long division now. Okay, so we're going to start with just some review problems on dividing, long division. So on page 88 of your notes, there's a notes section there, and you can just do these 2 problems in here. So let's go ahead and try this first one. Write this one down, 3,816 divided by 23. So first of all, we're going to draw our division bar down. We're going to put the first number always underneath. That's going underneath. The second number here is what we're dividing by. That's our divisor. So again, those names, the song was dividends underneath, divisors here, the quotient, which would be on top or will be the answer. So the first thing we're going to do is start looking to figure out, okay, how many times can 23 go into 38? And so that's just going to be a 1 time there. And we'll just multiply 1 times 23. It's going to be 23. And then we're going to subtract this now from 38 minus 23. That's going to give us 15, so 5 here and 1 here, so we're going to get 15 when we subtract. We then bring down the next number. And then we look at how many times 23 can go into our 151, and for this time it's 6 times. So 6 times it goes in, and so 6 times 23, we could do it separately by doing 6 times 3. It's going to be 18, so we'll have an 8 here, and we can carry a 1 there. 6 times 2 is 12, and then 1 more is 13, so 138. So when we subtract now 151 minus 138, we're going to need to borrow here for the 1 to help it out. So borrow from 5, make that into a 4. Now it's an 11. 11 minus 8 then would be 3, and then 4 minus 1 is 13. So 13 is what we get there, but now we need to bring down our next number, 6. So we get 136. How many times does 23 now go into 136? Well, we can see 138 was a little too much, so it's got to be a little bit less than 6, or 1 less than 6 would be 5. So 5 times, and then 5 times 23 again, so we're going to multiply first with 5 times 3, it's 15. We will carry that 1, which is already there. 5 times 2 is 10, plus 1 is 115 now is that number, which is 11 there, so 115. Subtract. So 136 minus 115, we're going to get a 1 here and a 2 here. It's 21. So 21 would be the remainder from this. Now I know you might be thinking we could get a decimal. If you remember that, we can put a decimal and add zeros here and keep going until we get a remainder 0. Sometimes that works and get a decimal answer. But we're just going to write our answer as a remainder here. And the way we need to write it is as a fraction remainder. So we're going to see our quotient here is 165. That's be our quotient. Our remainder then is going to be what you have down here. This remainder over 23 is going to be the entire quotient. So we'll say our final answer here on this one is going to be this, 165, and then our remainder here is going to be on top of this fraction over what we are dividing by, 23. So that's our final answer. We're going to leave it as a mixed number. You have your quotient and then your remainder over your divisor. That's going to be the entire answer. All right, so go ahead and pause the video, and you're going to do this one. 61,723 divided by 29. Do that problem and then play the video to see if you did it correctly. Okay, so hopefully you've finished this problem now. You're ready to just check your work. So go ahead and check your work against what I have here. You should have gotten a quotient of 2,128 and a remainder of 11. So that 11 is going to go over 29. And then if you didn't get that, then go ahead and pause the video and see where you may have made a mistake somewhere in your work as you were, dividing, multiplying, and subtracting, and then bringing down. All right, let's move on to our extra practice. Okay, so on page 89, we start our extra practice. We're dividing these polynomials with long division. So you have a trinomial divided by a binomial here. And so we're going to use our long division bar. And so we'll first put that down. And what's first is going to go underneath. Now, what we need to do is, as we're kind of writing this down, it is in descending order. We need to look for any missing terms. So we have it starts off with x squared. The next term should be the x term, which it is. So there's nothing missing there. And the final term should be a constant, and we have a constant. So there's nothing missing on this one. And then over here, x minus 3 starts off with x, then we have a constant. There's nothing missing there from x to that constant either. So if there's ever missing terms, we would have to fill that in with a 0, and we're going to see that, I think, on number 2 as we do that one. But there was nothing missing on this one. We're going to go ahead and just begin starting to multiply or divide this by dividing, multiplying, subtracting, and bringing down. So we have our kind of go-to term here. The very first thing is you got to realize it's going to, all the steps are like the long division. It's just now we have polynomials. So we have this first term right here. This is going to be our go-to term, x. We're going to keep figuring out now. We're not looking at what can the entire thing go into, just how many times can x go into an x squared is really what you're asking here in this case. So how many times can x go into x squared, or what do you need to multiply is the better thing to ask here. What do you need to multiply x by to make an x squared? Well, you need to multiply it by another x. So we're going to put an x up on top here. And now we multiply, using distributive property, the x times the x minus 3 to get two terms to go below here. So x times x is x squared. These two terms need to match. If they don't match, then you did something wrong. X times negative 3 is negative 3x. And now what we want to do is subtract. But when we subtract with polynomials, we have to change both of these signs here. So we're going to subtract these. So we're going to subtract the first one here. That's easy to do. It's just easy to stick that minus sign in front of this first one. But we also have to distribute that to the second one as well. So negative times negative will change this to positive. So basically what you're doing when you're subtracting is you're going to change the signs of what you have here. So you just change them all to their opposites. And now we combine like terms. And these two always should cancel each other out. So those do cancel each other out. And then 6x and 3x make 9x. And now we're ready to bring down our next term, the plus 12. And we go back to our go-to term here and ask ourselves, what do we need to multiply x by this time to get the 9x that's here? Well, we just need to multiply by 9. So we can say plus 9. And now we multiply with distributive property again. 9 times x minus 3. So 9 times x is 9x. Again, they match. 9 times negative 3 is negative 27. And now we subtract. And when we subtract, we change the signs. So we change the sign of the 9x here to negative. We change the sign of the 27 now to a positive. And as we combine like terms, these two should be canceling each other out. And now when you combine here, we're going to end up getting 39. So we get 39 for this one. So our remainder is 39 because we ran out of terms here. So we're at the end. The remainder is 39. So the way we're going to write our answer here is this. We're going to have our quotient that we had there, the x plus 9. And we're going to put plus the remainder as a fraction, where the remainder number here goes on top, and your divisor, what you're dividing by here, the x minus 3 goes on the bottom. So x minus 3 on the bottom, there is our final answer. All right, so number 2, start off with the division bar again. So let's put that down first, and what's first here goes underneath. So it starts off with an x to the third term. So the next term should be x squared, which we do have, so minus 4x squared. But the next term should be an x term, and we don't have any more terms. We ran out of terms. We need to include the x term by putting 0x. And after the x term should be a constant term, which we don't have, so we need to include that with putting 0. So you always need to include all the terms from the highest term here to the constant term, even if there's some that might be 0. And now our divisor is x squared, starts off with an x squared. The next term should be an x term, but it's not there. It goes to the 16. So we need to include the x term by putting 0x here. And then the next one should be the constant number, which they do include. The minus 16 goes there. Okay, so now again we have our go-to term as the very first one on the outside. We keep looking at that one to see, okay, what do we need to multiply x squared to get an x to the third? Well, that's just another x. It needs to be multiplied by x. So put up x on top, and then multiply x times all three of these. So you have x times x squared is the x to the third, so they match. X times 0x right here will give you 0x squared. So we'll just put plus 0x squared. And then x times the negative 16 is negative 16x there. We subtract now, which means we change all the signs to their opposites of what we just wrote. So then x to the third becomes negative. This actually doesn't really change signs. 0 is still going to be 0, but we might as well just say we would normally change that to a negative, and this would become a positive 16x. So as we combine like terms, we're going to cancel out our x to the thirds, and now negative 4 and 0 make a negative 4x squared, and 0 and 16 here make plus 16x. Now we do have this extra 0 at the end. We can put that there at the end, plus 0. We can bring down our last term. So now we go back to our go-to term. What do we need to multiply x squared by to get a negative 4x squared? Well, we just need to multiply by negative 4. So multiply here by negative 4 and then distribute that negative 4 to each of those three terms. So negative 4 times x squared is the negative 4x squared. Negative 4 times the 0x is just going to be 0x. We could put minus or plus. It doesn't matter because it's just a 0. And then negative 4 times negative 16, that will be positive, and 4 times 16 is 64. So we get a 64 there at the end. And then we subtract, which means change all the signs to their opposites of what we just wrote. So this becomes a positive. Now we can maybe make this a negative again. Make that 64 negative 64. So now we cancel our first two terms out. We end up having a 16x minus 0, so it's just going to be 16x there. And then we end up having 0 and negative 64, so negative 64 goes there. Now that is our remainder because we can't multiply x squared by anything to get a 16x. So we are done at that point. That is the remainder. We ran out of terms to bring down. So here's how we write our answer. We take our quotient up on top there, x minus 4. We're going to say plus the remainder as a fraction, which is going to be the remainder here, 16x minus 64. And it's all over what we were dividing by. Now when you write this one out, you should more put this one here, not with the 0x. You just want to say x squared minus 16. And that's that. Now the only thing we could maybe do is simplify this remainder a little bit, because we could factor out a 16 from this, and this can be two binomials here. So you might be able to cancel out something here, so you could simplify this fraction here, but I'm going to leave it that way for now. Okay, so problem 3 and 4, I'm going to have you try number 3, and then we'll do 4 together. But try number 3. Now that you've seen me do this long division twice, go ahead and try to do this one. Draw your division bar down, put the first one underneath. The second one, the 4x plus 1, put out in front. 4x is your go-to term. You keep asking yourself, what do you need to multiply 4x by to get that term you need? And so do that whole process of long division, and then go ahead and play it after you do number 3 to see if you did that correct. All right? Okay, so hopefully you've paused the video now at this point and you're playing it again to check your work on number 3. So here's what you should have for number 3. So number 3, you should have gotten an answer with no remainder. The remainder should have been 0, and it should be just x squared plus 3x plus 6. Let's just check it out and see what we should have done. And if you didn't do this correctly, maybe you can check and see where you made a mistake. So you're first going to start by asking, what do you multiply 4x by to get the 4x to the third? Well, you already have a 4. You just need 2 more x's, so x squared there. And you distribute that in, so it's 4x to the third plus an x squared, but then you change the signs to subtract. So that makes that a negative, makes this x squared negative, cancels those. 13 minus 1 gives you a 12x squared. And you bring down the 27x. So now you're asking, what do you multiply the 4x by to give you the 12x squared? That would have to be a 3 and an x, 3x. So 3x times 4x is 12x squared. So you're getting that. And then 3x times 1 is 3x here. But then you're going to change the signs in order to subtract. So changing the sign to negative here. So that way you can cancel those out. This becomes negative 3x. So we're going to subtract 3 from 27, giving us 24x, and bring down our last number, our constant term. And what do we multiply 4x by to get the 24x? That's just a 6. 6 times 4x is 24x. And then 6 times 1 is 6, and change both signs to negatives. And so then we cancel out the 24x's. 6 minus 6 leaves us with 0 remainder. So our answer is just what we have up here as the quotient, the x squared plus the 3x plus the 6. All right, so for number 4, we're going to go ahead and draw our black there. Put down your division bar. Now this one's a bit long here. We got x to the 4th, so an x to the 4th, we have plus 2x to the 3rd, and so we have an x to the 4th, we have the x to the 3rd term next, and you notice on this last one, I didn't mention it, but there were no gaps here, because you start with 3, then 2, then x, then the constant, there's no gaps. And this one, there's no gap so far, so plus 5x squared, the next term should be an x term, which we have, the 3x. The last one is not here, plus 0. And so we could put plus 0, but here's the interesting thing. This one also doesn't have the last term plus 0. So if they both don't have them, then you can just leave them off. It's only when you have one here and you have one there where you're going to need it. So these last terms here is the one that you could just not put there. Now, if it's anywhere in the middle, you're going to have to put a 0 and include that term. But the constant term, if you're missing the constant term on both of these, we can just go ahead and not put it at all, and we'll be fine. So our go-to term here is this x squared term. So what do we multiply x squared to get the x to the 4th? Well, that is another x squared. X squared times x squared is x to the 4th. X squared times x will be negative x to the 3rd. So now we're going to change the signs here as we subtract. Make both of these, well, make this one negative, make both of them their opposites. This now becomes plus. So cancel the x to the 4th. 2 plus 1 here is going to give 3x to the 3rd. Bring down your next term of plus 5x squared. And then what do you multiply x squared by to get an 3x to the 3rd? Well, you need an x and you need a 3. So it's going to be plus 3x. So plus the 3x here. So 3x times the x squared is 3x to the 3rd. 3x times negative x is negative 3x squared. And so again, we're going to subtract here. So change both signs to their opposites. So this becomes negative here. This will become a positive, so we can cancel those out. 5 plus 3 is 8x squareds. And then we can bring down our x to the 3rd here. So plus, or sorry, yeah, not plus the 3x here. Not x to the 3rd, sorry, 3x. And then we ask yourself, what do we multiply x squared to get the 8x squared? Well, we need to multiply by an 8. So plus 8 up here. We're going to put plus 8 there. And so we're going to get 8 times an x squared. So 8 times x squared is 8x squared. And 8 times negative x is negative 8x. Change both sides now as we subtract. And so this becomes a negative 8x squared. This becomes a positive. So those cancel each other out. 3 plus 8 is 11. So 11x is our remainder. And that's as far as we can go. And notice if I had put plus 0 on the ends of these, I wouldn't have needed it because I ended up bringing 0 down, you know, and we still would still be at the same place. You know, we have 11x plus 0, and we wouldn't need even to say plus 0. We just say 11x. So our remainder here is 11x, and so our answer for this one now is going to have the quotient x squared plus the 3x plus the 8, and then plus the remainder. The remainder is the fraction of 11x over just this binomial x squared minus x. And there's our answer. Okay, so that is the long division. Hopefully you got the idea of how to do long division. We're now going to do a different method of doing the same thing, of dividing these, but it's called the synthetic division, which I think of just as the shortcut method. So let's take a look at the synthetic division now. Okay, so starting with number 5, we're going to look at this division using synthetic division. And so you can see it looks exactly the same. We're just going to do a different method here, a different way, and I think of it kind of as a shortcut. So the first thing we need to do is figure out what I like to call the multiplier number. That's going to come from your divisor here, what you're dividing by. So basically you would take this, x minus 2, and set it equal to 0. And solve this little equation for x. If we solve this for x, we add 2 to both sides, so x equals 2. That is the multiplier. 2 is the multiplier. And so that's how you can get your multiplier number. That's the first thing to do, is to find that number. And then we're just going to put that number down kind of a little separate. I just put a 2 and a little bracket around it or something like that just to separate it out. And then what we do is, next to this, we're going to just put the coefficients of this dividend. This is normally what would go underneath the division symbol, but we're just going to put the coefficients. So that's the numbers in front here, or just the number itself, the big numbers. So this first one is a 1 because we don't see it. It's got an x squared term, and again, the same thing will apply if we're missing a term. So if we miss a term, we need to put the 0 for the coefficient number. So we always have to include every single term that we have. So we start with 1. We're going to put a 1 for this coefficient, then this next one's negative 10, and then the last one here is positive 2. So we just have the 3 coefficients coming down. We're then going to leave a little bit of space under that, draw a line, and then now we start to do our first term. So the first thing you do is you're going to bring down this first number down to the bottom. Whatever number that is, that comes to the bottom below the line. So 1 goes down below. Now we're going to multiply this number times our multiplier. That's why I call it the multiplier, because it's what you multiply by. So once we brought our 1 down first, that kind of gets it started. Now we do 1 times 2, which is 2, and that's going to go underneath the negative 10. So it's just above the line, but underneath negative 10. And now what we do is we combine these two numbers. So negative 10 and positive 2 would make negative 8. That goes down below. So it's kind of like you subtract here, or add, just combine the two like terms here. So this makes negative 8. Now we take that number and multiply it back again to the multiplier. So negative 8 times 2, that's negative 16. That now is going to go underneath the 2, but above the line. And then again, we combine these two numbers together, take 2 away, for that's going to be negative 14. So that's the whole process. Now what we want to see is, we're going to look at the numbers below the line now. We're going to separate out this last number. So the last number is special. So we're going to draw a line and separate that out and see, okay, this is a special number. So on this side, the left side of this line, this is your quotient. And then on the right side is your remainder. So that's why I always want to put a line there to separate the quotient from the remainder, so I can see clearly which one is which. And so now, as far as the quotient goes, this first number, negative 8, would be your constant term. The next one in front of it would be your x term. And so that's going to be what our quotient is 1x minus 8, or just x minus 8. And then a remainder is negative 14. And we're still going to write the answer the same way. We're going to put the negative 14 over what we were dividing by, which is not the 2, it is the x minus 2. That's really what we're dividing by. So divided by this binomial. So our answer should look like this. Here's our x minus 8 plus the remainder over what we're dividing by, x minus 2. That's our divisor here. Okay, let's go ahead and try number 6. So start off by finding the multiplier. That's going to look at this right here, x plus 2. So it's what your divisor is. So remember, if you just were to subtract 2 to solve this, if it said equals 0, your multiplier is going to be negative 2. So this time it's negative 2. It's almost like, what would you put in here for x to make this equal 0? And that would be negative 2. That's the multiplier number. We're going to put that on the side over here separate. And then we write down our coefficients. So I have an x to the third term, and that coefficient's 1, so we start with 1 again. then we should have an x to the second term, which we do have. So they include that term, and that coefficient's 4, so we're going to put a 4 down. The next one should be an x term, which we have included an x term there. So plus 6, or 6 is that one. Notice I didn't put plus 4 plus 6. If it's positive, I just put the number. It's only when it's negative, like over here, negative 10, I put the negative sign. And then after the x term should be a constant term, which we do have included, which is 4. We'll leave a little space and draw a line and bring our first number down below the line, just to get the synthetic division started. So now we multiply that times negative 2, which is going to be negative 2. That's going underneath 4. So underneath 4 there, and then we subtract here. 4 minus 2 will be a 2 under the line. And now 2 multiplies the negative 2. That makes negative 4. That's going to go underneath the next number. So 6 minus 4 is now going to be 2 under the line. And now 2 times negative 2 again is also going to be negative 4. So negative 4 here, and 4 minus 4 is going to give us 0 under the line. So again, I draw a line to separate out this last one so that I can see my quotient on the left side and my remainder number here. So we have a remainder of 0 this time, which we need to know we're not going to need to put a remainder on this one. It's just going to be the quotient. The first number here next to the line is always your constant number. So there's no variable for that one. But this next one is got the x. So that one's going to have the x, and the one in front of that one would have an x squared. If there was a third one, there'd be an x to the third, and it would just keep doing that. So here's our answer. We're going to have an x squared plus 2x plus 2. So here I put back our plus symbols, right? You need to make sure you put plus 2x plus 2 as you're writing your answer down, because the answer is a trinomial. And trinomials have to have these polynomials have to have plus or minuses between the terms. All right, let's keep moving on to number 7. Okay, so number 7, we want to again start with finding our multiplier. That's going to come from the x plus 3 here. So what would we need to make x be to make this equal 0? That would have to be negative 3. So this is always where we're going to find our multiplier from after the division symbol. So negative 3 is the multiplier. Let's go ahead and put that down, and now we're going to put our coefficients down of our dividend. It starts off with an x to the third term, and that coefficient's 2. So we're starting with 2. The next term should be an x squared term, which we do not have included. So we need to include a 0 for the x squared term. It's missing, so we have to have a placeholder to show that's where the x squared term would be. After x squared would be an x term, which also are missing the x term. So we need to include a 0 to represent the x term. After the x term would be our constant, which we do have here. It's negative 54 then at the end. Leave some space and then draw a line. And we're going to bring down this first number. 2 goes below the line to get started with the synthetic division. And so now we multiply 2 by negative 3. Now since you've seen me do this now a few times, go ahead and pause the video and see if you can now finish up this synthetic division and get your answer and write your answer properly. So go ahead and pause the video and try it. Okay, so hopefully you finished number 7, and now you're just going to check to see if you did that correctly. So 2 times negative 3 is negative 6. 0 and negative 6 make negative 6 there. Negative 6 times negative 3 is positive 18. 0 and 18 make 18. And 18 times negative 3 is negative 54. And those two make a negative 108 when we combine them. And so I always draw the line there to show this is our quotient, this is our remainder. So there's our constant term. 6 is the x term, and the 2 is the x squared term. So our answer for this one is 2x squared minus 6x plus 18 plus the remainder, negative 108, over what we were dividing by, which always is this right here, x plus 3. All right, so on to number 8. So I'm going to have you start this one from the very beginning this time. So you're going to start by finding the multiplier, which comes from here, and put that down, then put all your coefficient numbers down. And I notice there's no gaps here. As you can see, there are no gaps to fill in with zeros like we had over on this one, number 7. So go ahead and fill the whole thing out, do it with synthetic division, get your answer, and then go ahead and play the video to check to see if you are correct. All right, so you're checking your answer for number 8. So here we go. Our multiplier should have been 4. So 4 is the multiplier. There's our coefficients, 2, negative 11, positive 11, 4, and 4 again. We draw our line, and we bring down that first number 2. And then 4 times 2 is 8. And then you subtract that. and you're going to get negative 3, which is now negative 3 times 4 is negative 12. We're going to subtract again here, get negative 1. Negative 1 times 4 is negative 4. Subtract again, and we're going to get 0. 0 times 4 is 0, and 0 and 4 make 4 for the remainder number. That's our remainder here. Here is our quotient on this side. So 0 is the constant. There is no constant, which means you don't need to include 0 in your answer. You're going to start with this being your x term. So we have our x term. Our x squared term is the 3x squared, and then the 2 is going to be an x to the third term. So our answer for this one's going to be here, 2x to the third power minus 3x squared minus x. We don't need to include the 1. We can just say minus x. And we're not going to include 0 because we don't need that. Plus the remainder, 4. Your remainder number is 4 over what we're dividing by, which is the x minus 4. All right, hopefully you did that correct. And you are getting the idea and the hang of synthetic division. So as you're kind of seeing that you can divide these polynomials one of two ways, long division or synthetic division. You can kind of decide which one you like better, which one's easier for you. Sometimes synthetic division is a little bit faster, but sometimes they do want you to do long division, and the problem, is in the sense designed for long division. So, but at this point you can be, using one of the other methods. But if it says long division, use the long division. If it says synthetic division, then use synthetic division for now, just so you get the hang of both methods. Okay, our joke of the day. Which bus crossed the ocean? Which bus crossed the ocean? Here's a little history joke of the day. Columbus. He sailed the ocean blue in 1492. Okay, next thing we're going to look at is this thing called the remainder theorem. Sounds kind of maybe challenging or difficult, but it's not. It's very simple. It is really just an evaluating problem. And remember, every time it says evaluate, we're basically plugging a number in for x into the function and then getting an output as our answer. So it's really just an input-output situation. That's what the remainder theorem is. So the multiplier that we've done before, so you look at your divisor, you find your multiplier. So again, you're still going to find the multiplier here, like synthetic division. With remainder theorem, you're going to find the multiplier as well, that same number. So the multiplier in this case, though, is our input number. We're going to put that into our function, and then the remainder would be the output. And that's what we're looking for. It's going to just say, find the remainder. What is the remainder? And that's all it's going to ask for is just the remainder. So we can find that by plugging in our multiplier number into the function, and our output will be the remainder. Just go ahead and write that down on page 88, right underneath this core concept. You probably wrote down some problems there from the beginning, but you might have some space still to write this down. Okay, so problem 9 through 12 are matching here these division problems to the quotients. And to do this, we don't have to do the entire long division or even synthetic division to match this. If we can see our quotient, what we can do is just use the remainder theorem, because we can see our remainder numbers. On A it's 4, on B it's 12, C is 28, and D is 20. So they all have exactly the same divisor. The dividends are a little bit different each time, but they all have exactly the same divisor, x minus 4. So again, to use remainder theorem, we want to find out that multiplier number. In this case, it would be 4. X would equal 4 for the multiplier number, because that's what would make this 0 in here. And so that was going to be our input number. We're going to input x into our dividend, where x squared is and the x is. So as I plug that in, it's going to say this, 4 squared minus 4 minus 8. And then we know 4 squared is 16, so it'll be 16 minus 4 minus 8. And then as we subtract some things here, 16 minus 4 is 12, and then 12, we'll see 12 minus 8, then that's going to end up being 4. So our answer there is 4. That's the output, and the output is the remainder. So the remainder for this one is going to be 4, so we can see that we have letter A. 9 is letter A because the remainder is 4. So that one's A. So go ahead and pause the video, do 10 through 12, figure out which one these 3 match up with the other 3 down here, B through D. And then go ahead and play and see if you got that right. Alright, so using this remainder theorem, you should have continued on with 10 through 12. So we're going to plug 4 in. So this one's going to be 4 squared minus 4 plus 8, which is going to be 16 minus 4 plus 8. So 16 minus 4 is 12 again, but now we got 12 plus 8, which is 20. So that's the remainder of 20, which is letter D. And then for 11, we're going to plug in 4 here. We're going to 4 squared. It's going to be plus 4 minus 8 this time. And so we got 16 plus 4 minus 8. So it's going to give us 20 minus 8. And 20 minus 8 is 12. So that's the remainder of 12, which is letter B. And then the last one, obviously we know our last one. Let's just go ahead and plug it in because they do want us to justify our answers. So if I plug it in, it's going to say 4 squared plus 4 plus 8. So that's 16 plus 4 plus 8. We're just adding all those together. So 20 plus 8 is 28, which is the last one, letter C. All right, just using the remainder theorem, we were able to figure out what the remainder was, so we could just identify which one was which over here. All right, moving on to number 13. Okay, so in 13 to 16, it says use synthetic division to evaluate the function for the indicated value of x. So we've seen problems like this before where they're given it to you like this. We've seen this actually on, I think it was 4.1 lesson, where it gives you a polynomial function here and it says x equals 2 and they want you to evaluate for the indicated value of x. And normally what we do is we plug in 2. And so we take 2 and we plug it in and figure out what the output is. The output is our answer. Again, these make ordered pairs here. So again, you got to keep thinking of that terms. So that also makes a kind of connection to your remainder number and your multiplier number, because those are also like the ordered pairs that you would see. X would be your multiplier, your y would be the remainder number. So we're going to use synthetic division. Now we don't need to find the multiplier because it's already given to us. This is the multiplier. 2 is our multiplier. So we can start with that. Now we're trying to find what is the remainder when we're trying to evaluate. We don't need to write the whole entire answer out. We're just going to look at the remainder number, and that's our answer. So that's why I wrote right there. You just want to say, what's the remainder? So you may want to write that down. So starting off with your multiplier, it is 2. Our coefficients here, starting with the first one on the x to the third term, it starts with -3, then +4. And again, I'm looking for gaps as I'm putting these down. -17, no gaps so far. I'm not missing any terms. -6, there was no gaps on this one. Draw our line, so leave some space, draw the line, and bring down that first number, -3. Here's where we start the synthetic division. -3 times 2, so -6 goes under 4, and then you're going to subtract those numbers and get -2. -2 times 2 is -4, is going to go into -17. Here we're going to add and make it a bigger negative. So it's going to make a -21. -21 times 2, that's going to give us -42. Again, we add these numbers. They're the same sign, so we add and get a bigger negative. It's -48. I separate that last one out. So again, there's my remainder, there's my quotient, but I'm not going to care about the quotient right now. All it wants me to do is to evaluate, which is just identify the remainder. So the value, evaluating the function for the indicated value of x, when we evaluate the function for 2, our output would be -48. That is our answer. So -48 is our answer, and that's all we got to do. Okay, you went on to 14. Our indicated value here, x equals -1. So that's our multiplier number. Start with putting that to the side. And now for the coefficients of what we have here in our function, starts with the x to the fourth term. So that's a -1. X to the third, well, that's not there. So if it's not there, we need to represent it with a 0. So x to the third is represented with 0. The x squared term would be next, and that one is here. The coefficient of that would be 1. The x term, well, the x term is not here, so we have to represent it with a 0 also. And then the constant term is the last one, that's a 4, so that's represented already. So there's our numbers, and we had a couple zeros in there because we were missing 2 of the terms from x to the fourth down to the constant term. So make sure you don't ever miss those missing terms. You got to put zeros in there. If you didn't do that, if I just put -1, 1, and 4, I would see that that would not be, something would be wrong as I'm working this out. It just wouldn't come out right. So we have to put those in there in order to have placeholders so everything is lined up and comes out correctly. Here we draw our line and then bring down that -1. -1 times -1 is +1, and we add those together, we just get 1. 1 times -1 is -1. Here we're going to subtract, and that'll give us 0. 0 times negative 1 is 0, and the two zeros will make a 0. 0 times negative 1 again is 0, and 4 and 0 make 4, and that last one is the remainder number, which is what we're looking for on this problem, because that's what it's asking us. So you got to make sure you read the instructions of what it's asking you. You don't have to do the entire long division, or you don't have to plug it in. You know, it's just asking to use synthetic division to do this. Now, could you just plug it in like we did before in the last problems that we were matching with? Yeah, you could. So, you know, it's the same thing. You're getting the same answer. You're just trying to find, again, like an ordered pair. If x is negative 1, what would the y be? Y is 4. That's our answer. 4 is the answer on that one. Okay, now that you've seen me do this twice, go ahead and try 15. Use synthetic division to evaluate this. Here's your multiplier number right there. Go and write your coefficients down and work through the synthetic division. So pause the video and then play it when you're done. Alright, so number 15 should be completed. Here's what you should have for 15. Your answer should be negative 560, because that's what the remainder number would be. So that would be your answer here. So if x is negative 5, the y would be negative 560. And so if you can see, if you didn't get that number, see maybe where you made a mistake in your synthetic division here. Pause the video again and see if you can figure out your mistake and then fix that mistake. Alright, for number 16, I wanted just to show you that, you know, could we, even though it says use synthetic division on this, could we just plug 3 in? And of course we could. So I'm going to do that one by saying I'm going to plug 3 in. So f of 3 is how we kind of do this. And then if we just plug 3 in, we can do 3 squared, and then 8 times 3, then the plus 27. And we could do the problem this way. So 3 squared, that's going to be 3 times 3 times 3, which is 27. 8 times 3 is 24, and then another 27. We add these three numbers up. 54, I just did 27 and 27. I made 27 and 27 become 54 plus 24, and those two add together to give us 78. So our answer is 78 if we are to do synthetic division, which, why don't you go ahead and try that. Do the synthetic division with this one and see if you get 78. But you'll have to notice you're missing in the x squared term here, so there's going to be a 0 for the x squared term there. So if you try that, you can confirm your remainder would be 78. Alright, we have one more to do and then we'll be finished with this lesson. Okay, so here's our last problem, number 17. It says, what is the value of k such that this dividend here, and there's k. So k is right there. So it starts off with x to the fourth term, gives us an x squared term, an x term. We want to know what the coefficient of that x term is. So what is the value of k such that this divided by x minus 4 has a remainder of 0? So we have a couple ways we could do this. Now, we've talked about how to get a remainder here. There's a remainder theorem that we could use. We could use that, or we can use synthetic division. So basically either one of those would be fine and would work. So in either method, you have to get your multiplier number, which is coming from x minus 4 here. And we can see that would have to be 4. So x would equal 4 for our multiplier. Now I'm going to use the remainder theorem, and that means I'm going to basically plug in 4 into this. But remember, we want to make this an equation. So we would need to make this an equation. If we use synthetic division, that would be kind of more guessing and checking. I think this would be the more straightforward and easier way to do it. If we said, okay, the remainder of this, when I plug in this, what I would get out when I plug in 4 for x in each place, what I should get is 0. So I'm going to start plugging that in here, starting with the x to the fourth term. So negative 4 to the fourth power. And this is just a remainder theorem, just plug an x in. 5 times 4 squared, that's our next one. And then plus k times the 4, so k times 4, minus 8. So when I plug this in and work this out, I need to be able to get 0. So I'm just going to say equal 0. This is going to equal 0. When I plug 4 in, it's supposed to equal 0. So now that makes an equation for us. We can just solve this like a regular equation for k. So we start off with our first term up here. So we're going to do 4 to the fourth, then multiply it by a negative. And if I multiply 4 times itself 4 times, 4 times 4 times 4 times 4, that is 256. So that's a negative 256 when I multiply it by a negative. 4 squared is 16. 16 times 5, that's going to give us positive 80 there. k times 4 is just going to give us a 4k. And then minus 8 equals the 0. And so now we're just going to combine some like terms here. So we have these three numbers we can combine, negative 256, positive 80, negative 8. So we'll start off with 4k, and then after that we'll have, or actually I'll put I guess that first here. You could put 4k first, but negative 184. So negative 256 plus 80 minus 8 gives us the negative 184. And it's still equal to 0. So now all I have to do is just add the 184 to both sides. So get the 4k by itself, add 184, and I'm going to cancel out my 184s here. And so 4k is going to equal 184. Divide by 4 now. And so our answer, when I divide 184 by 4, we can do that on a calculator. 184 divided by 4, that would give us 46. So our answer for this one, k, is equal to 46. All right, so that does conclude our lesson on dividing polynomials, and I'll see you on the next lesson. Don't forget to do your assignment.